Welcome back to my channel. Myself SN Kubendra from Sri Venkateshwara College of Engineering. So today's course subject is gonna be about discrete mathematics and structures. And today's topic is gonna be about mathematical induction. So let's start. First, the introduction part. Mathematical induction is a proof of technique used to establish the truth of a infinite number of statements. Well ordering principle. Every non-empty set of non-negative integers has a least element. Recursion definition. Defining a sequence or function in terms of themselves. Counting principle. Fundamental rules for counting including permutation and combination. So let's start with mathematical induction. Definition. A method of proof used to establish that a statement is true for all natural numbers. Base case. Prove the statement for the initial value, usually n is equals to 1 or n is equals to 0. Inductive step. Assume the statement is true for n is equals to k and prove it for n is equals to k plus 1. The well ordering principle. Definition. Every non-empty set of non-negative integer has the smallest element. Implications. Fundamental to proofs in number theory and is the basis for the principle of mathematical induction. Prove that any subset of non-negative integers has a minimum element. Recursion definition. Definition. Defining an object in terms of itself using a base case and a rule for generating subsequent elements. Common recursive structures. Sequences. Fibonacci sequence, where f of 0 is equals to 0, f of 1 is equals to 1. And here this is an important formula. F of n is equals to f of n minus 1 plus f of n minus 2 for n greater than equal to 2. So this is an important formula which must be kept in mind for VTO examinations. Next, functions. Factorial function, where n factorial equals to n into n minus 1 factorial, with 0 factorial being 1. And this is used in algorithm design, particularly in computer science. Fundamental principles of counting. Rules of sum and product. Sum rule. If there are n ways to do one thing and m ways to do another, and these two things cannot be done simultaneously, there are n plus m ways to choose one of the action. Product rule. If there are n ways to do one thing and m ways to do another, and this action can be done in a sequence, that is one after the other, there are n into m times or n into m ways to perform both actions. Examples. Sum rule. Choosing a dessert if there are 3 types of cake and 2 types of pie. Product rule. Creating a license plate with 3 letters followed by 3 digits. That is, in sum rule, we just take choosing a dessert if there are 3 types of cake and 2 types of pie. 3 plus 5. That is 5 ways to choose a single dessert from the following example. And product rule. Creating a license plate with 3 letters followed by 3 digits. So it is in a sequence. 3 letters followed by 3 digits. That is, first 3 letters and next is 3 digits. That is 3 into 3, that are 9 ways. Permutation. Permutation of n objects taken r at a time, that is p of n comma r, is equals to n factorial divided by n minus r factorial. This is the permutation formula. Definition. An arrangement of objects in a specific order. The number of permutations of n distinct object is n factorial. Arranging 3 books on a shelf is 3 factorial, that is 3 into 2 into 1, that is 6. Combinations. A selection of objects without regard to order. Formula. The number of combinations of n objects taken r at a time is C of n comma r is equals to n factorial divided by r factorial into n minus r factorial. Examples. Choosing 2 out of 5 friends to go to a movie, that is C of 5 comma 2, that is equals to 10. There are 10 ways of choosing 2 friends out of 5 friends. Combination with repetition. Formula is C of n plus r minus 1, comma r. The binomial theorem. So this is a statement and formulas. X plus y to the power n is equals to sum of k is equals to 0 until n, c of n comma k into x n minus k y of k, y power k. Expands the powers of a binomial expression. This is expand of x plus y whole cube is equals to c of 3 comma 0 x cube y to the power 0 plus c of 3 comma 1 x square y to the power 1. So this is the summation expanded version. So here we are taking x as 3 and y as 0 at first interval. Here c as x as 3 and y as 0, following here n minus k 3 and k as 0. So n is the first value, x 3. So n value is 0 here, so this is 3 stays as it is. And here it reduces to 2, it follows, goes on. And then used in probability, algebra and calculus. Next. Summary. So we are at end of our presentation. The summary is mathematical induction is a powerful proof technique for infinite statements. The well-ordering principle is fundamental in mathematics. Recursion definition provide a method to define sequences and functions. Counting principles, permutation and combinations are essential tools for solving combinatorial problems. Practical applications. These concepts are widely used in computer science, mathematics, statistics and various scientific disciplines. Thank you for watching. Do like, subscribe and share this video as much as possible. Thank you for watching. Bye bye.
From the dust and clear my throat.